Hello, I'm Kush Malwatkar, and this is my submission to the WPI Design Innovation Scholarship. I'm the project manager of FRC team 2791, and I joined the team in my freshman year. Although coding is my background, I do love project management the same. There are three main subsystems on the robot except the drivetrain, and the three of them are the intake, the elevator, and the scorer. We call it the scorer because scoring coral in the game, in the Reefscape game. We have an intake, which is a active intake, which has two rollers on either side, which allow the funneling of the game piece, which is called the coral. The elevator, we have a two-stage elevator on our robot, which extends up to the height of a bit more than 6 feet, which allows us to get the L4 scoring in the Reefscape game. The scoring mechanism is a basic mechanism with a compression motor, with compression wheels on two motors, which spin in opposite directions to score the coral. And obviously, then we have a swerve drivetrain. This is our second year we've been doing swerve, so it's a new thing for us to explore as well. So this year we are taking a different robot philosophy as compared to previous years. In previous years, we built the most advanced, most capable robot and had like 2 days to drive practice and program the robot. So this year, to remedy that issue, our plan was to make a much simpler robot which did the main functions, so we can do very well in an early week competition and make it to the world stage. We noticed that we had two different sub teams for design and assembly, and we combined those into a single large sub team called mechanical. The reason for that change was that we were noticing some miscommunications between the design sub team and the assembly sub team, and now that they're basically one sub team, they will have a much better idea of what the robot looks like to be able to build it more effectively. And similarly, the design team will also know what is feasible assembly wise and what's a little out of our comfort zone in terms of team proficiency with tools and things. Even though a robot isn't as complex, there's still a decent amount of complexity and mechanical systems that are on this robot. The brain pan has a lot of complex electronics under it. So it contains the Rio, the power distribution panel, and the Navex, which is our gyro. So what we're using this year is a Rio 2.0, which is the next generation of Rios introduced a couple of years ago, and the Navex 2 as well, which is the next iteration of the gyro as well. And those are mounted on the underside of the robot. Now, what that implies is that now our one of our axes is flipped. The rotation axis is flipped, and we have to account for that in the code by inverting the gyro. We also plan to use our intake system as a dynamic intake system, which can use different speeds for both rollers to help funnel the game pieces inside the robot better than, say, if it was just the same speed or if it was too slow or too fast and whatnot. We were using the Rev hardware client for all of our testing, and we plan to shift over to real robot code once we have all those things finalized. What we are using programming wise is we're trying to make it very simple and intuitive for the driver to make certain movements on the robot. So for example, the elevator is going to have presets for L1, 2, 3 and 4, which are just buttons on the controller. So overall, FRC has been a wonderful time of my life. I came across robotics and got completely engrossed in it. I was watching demos as they happened. I was involved in troubleshooting. I was involved in basically everything programmatically, and then I branched out to more of a general robotics aspect as time went on. I plan to go to WPI for robotics engineering, mainly because of what FIRST has done for me and what I've learned from it. Thank you.